think that's an excellent question. In the industrial internet, there are two things we think about. One is the data that moves from the device to the cloud or to some type of processing unit, and then the control signals that eventually get pushed back into the device. So if you think about a high-speed internet, in many cases, if you have a situation in which we can't get the signal back fast enough or can't get the actual action back fast enough in which to do it, we would have to create a situation in which we have an edge device, and the edge device is the one that has to do the computation or have the model in it. And so in a situation like that, you have a number of edge devices, and the machine will communicate with the edge device and then will get information sent back. Now if I have a high-speed network, in some cases I can go directly to the cloud and have models that live on the cloud. Now what's the difference between the two? A model on an edge device is much smaller. It may be less accurate. It may be capable of doing a lot less. So I may have smaller digital twins or smaller models at the edge. If I have the high-speed bandwidth that gets me back to the cloud, in which I can do massive computation quickly, I may have a much richer model with capabilities or a model that is much more accurate. So the presence of bandwidth gives me a very big advantage in terms of the type of models I can run and the outputs I can get. So I think that's a huge advantage here. GE is applying AI in three ways with the digital twin. First, in the actual acquisition and preparation of the data itself. We have situations, for instance, in many shops in which we have used AI technology, especially our computer vision, to actually detect cracks, or at least to localize the area in which a crack could be detected, and to help a technician find those cracks. That's using machine vision and neural net capabilities. We also use, in the same data context, AI to actually allow us to impute data. When some data sources can't be found, we can use machine learning techniques to impute the right data that we need in order to actually drive the correct calculation. So the second way we use AI techniques is all around this notion of an assistant. We have tools, for instance, there's a great one called usage-based lifing, in which we create lifing models, but it also can be used to create performance models or behavioral models. We have assistants. The assistants look at what we're typing. We might be looking for or asking about models that are related to scrap, that are related to a certain type of turbine or a certain type of technique, and it can suggest to you models that have been created and give you the names so that you can make the connection with that person and use that model. It'll also give you information like, here's the accuracy of the model, here's the data it's been used with, here is the type of performance of the model itself. So that's as an assistant. And third, we use AI in the learning context. In many cases with digital twin, we have running models, and there'll be a time in which you want to update that model because something in the environment or usage has changed. It can detect that using the right AI techniques and tell you when we should update the model. We can also use AI in transfer learning. We can apply models we've created for GE90 and transfer them across to the LEAP engines using some of those AI techniques. So AI is used both in the data acquisition and in the advisor, administrator roles or assistant roles, as well as in the learning roles. So a number of ways, and we're continuing to advance the use of AI throughout GE. I think there are two things here that should be considered. One is this notion of the brilliant factories around digitization. Digitization of the factories themselves, I think, is a very, very important thing. In many cases, there have to be novel ways of digitizing something. It's an easy way of digitizing something is maybe taking a small device that could be running with a Raspberry Pi or some other small sensor and tying it to a machine and then using that as a way to gather data. But other people are using other devices that give you equally as good results. You could be using sensors, cameras that actually look at the speed of packages moving along a conveyor belt, using that to pick up data. infrared to determine certain hotspots in the factory, using that to get data in. So there may be ways to think about the data acquisition process in a way that's cheap and meaningful, and in no way does it break into the normal processes within the factory itself. The other discussion that would be interesting is trying to understand how we could build simulations and reuse simulations about certain types of processes in the factory, whether it be optimizing a line for throughput, whether it be looking at free cash flow or inventory management. We have created capabilities in GRC and part of G Digital that are called patterns. One pattern is a scheduling pattern. And this scheduling pattern allows people to reuse pieces of simulation patterns around factories and environments like hospitals and workflow environments, in which they can use those quickly to try to estimate what is the entitlement of a factory or a line and of a process, and from that determine what are the gaps. Where can I fill those gaps? So I think it's two things. One is around the data. How do you actually bring in more data from a variety of sources? And the other is to actually look at some of the packages we have and the patterns we have around simulation and use those to try to understand the entitlements and the actions that you need to take. Those are two I would suggest. I think that would be the foundation for innovation to rise. And I'm sure there'll be a lot of innovative ideas that would come out of the work that we're doing here.